Hello there, 7th grade. Welcome to the lesson on section 712. I'm going to give you a quick heads up. We are going to be jumping through sections throughout the rest of the book. We're going to do 4 or 5 sections more out of chapter 7. We're going to do just a few from chapter 8 and then a couple from chapter 9. Our goal is to kind of hit some of the high points before the end of the school year. This section is going to cover scaling values and quantities. So we're going to start off with section 712. How do you make something bigger or smaller? The idea is basically that you can change between percents and fractions, and then you can multiply or divide. And what's going to happen is that you will make shapes either bigger or smaller based off of that. Sometimes, though, you will have weird percentages, like in the intro here. It says, earlier on in chapter 5, you learned how to find percentage of a number by making a diagram. And it's a pretty straightforward calculation when it's an easy one, or if it's a fraction. But sometimes you might have weird decimal values like 6.3% or 84.5%. All that means is that there's ways for you to get around doing this with those numbers, and I'm going to show you a couple of those. So we're going to start off 716. It's got Dan is training for a bicycle race. He can ride his bike 25 miles in 1 hour. One day he'd been riding for 3/5 of an hour and he had to stop to fix a flat tire. So one way to look at this is to think, okay, if you wanted to find the missing piece, you could do this by breaking this up into 5 sections. Because it's out of 5, you could think of this as 1, 2, 3, 4, 5 sections. And each of these is 5, 10, 15, 20, 25. So 3 out of 5 is going to be 5, 10, 15 miles. So you can do this because the numbers are nice and easy to break up. It's 3/5, and so it's just 25 divided by 5. But what's interesting is that if you pretended that this was a shape, or just a proportion or a scale, and you knew it originally was 25 miles, and he only went to 3/5 of that size, all you have to do to find the new value is to take 25 times 3/5. And when you multiply a whole number by a fraction, it's pretty straightforward. You do 25 times 3 for the top, which is 75, over 5, which gives you 15, which is what we figured out earlier. The main idea is that instead of chopping it down into fifths or tiny little pieces, what you can do is that you can actually just multiply by the fraction or the decimal value. So one good example of this is, what is 90% of 25 miles? So I've already shown you ways to do this, so this lesson may be a little repetitive for you guys, but 90%, you could think of this in 2 different ways. You could either call it 90 out of 100, which is the fraction version of it, of 25, and you can put that over 1 because we're multiplying fractions. And you can simplify it that way, where you say 90 out of 100 times 25, and that's not a bad way to do it, except it's going to give you a little bit of a difficult answer to figure out. I personally would recommend that when you see a percentage like this, that you take 90% and call it the decimal value of 0.90. Because if you had 90% originally, you go 2 spots left, and you get 0.90, and then times 25. Okay? And even if you don't get a number that is, a whole number, that's still fine. In this case, 0.90 of 25 is going to be 22.5, which is okay. 8% of $75. Again, I recommend that you write the percentage over here, like 8 point nothing percent. 2 spots to the left. Fill in the blank spot to make it 0.08 times 75. Okay, and you will get 6 out of this. And 25% interesting because yes, you could do 0.25, but this one's actually easier if you recognize that 25 is another way of writing a quarter. And so it is 1/4 times 144. And then you can simplify it that way after you've done that. Okay, you could just simplify that. So this percentage idea shows up most often when you are out eating dinner or calculating a percentage tip. And there's a lot of shortcuts that people use and get by, but an easy way to do it is to just take whatever this percentage is, like 15% tip, you do 0.15, my screen closed, oh well. Okay. In that case, if you have the percentage tip that you were working with, okay, it is 15% of $38, so you do 0.15, because again, 15%, 2 spots to the left is 0.15 times the $38. Okay, you don't have to change these to fractions always. It's not always easiest to go fractions. In this case, it's pretty easy just to multiply the decimals. 0.15 times 38 gives you 5.7, or in other words, $5.70. Okay. Yeah, I'll just leave you with the idea of try this to do 20%. Figure out what 20% of that is. And I'm going to jump into the homework help. I actually kept that video shorter than expected. Woohoo. Homework help. So if you've got a start of this, you've got a boat traveling 35 miles per hour. Fishing spot is 27 miles away. If she drives her boat for 2/3 of the time, will she make it? So you're going to multiply 2/3 times her speed, which is 35 for 1, and then figure out if she has gone 27 miles. If you want to know how long it's going to take her to get there, that's going to be a little bit more challenging. But the easiest way to do it is if she has to go 27 miles to get to the spot, out of the 35 miles that her boat goes, that's a fraction of an hour that you can just deal with. You can leave it like that. 7-22 is tricky because you have to think 6 times what number equals 5, and that's what's going to go here. And most of the time there's not a nice easy number that takes 6 down to 5. But if you remember fractions and the way to find a scale factor, you find a scale factor by dividing. So my scale factor from A to B is to just do 5/6. And when I multiply 6 times the 5/6, what's going to happen is I get 6 times 5 is 30 divided by 6, which is back to 5. So you're going to find that these are reciprocals of one another. If you don't remember the word reciprocals, it is them flipped of one another. And that's the answer to part C, actually. Okay. 7-23 looks awful, but it's not actually that bad. You are not supposed to solve these. It does not say get x by itself because there's no equal sign here. What it is asking you to do is just combine like terms. So that means I have 1/2 of an x here, and I am adding 3/5 of an x to that. I need to calculate 1/2 plus 3/5. And I do that with a common denominator of 10. You have 5/10 plus 6/10 gives me a total of 11/10, but this was caring about x's, so this is 11/10 of an x. And it's fine, it's just a weird thing. And then you're going to repeat this process for 7/12 minus 2/3. Part B is also very similar, except you have a like terms with a negative 2.8 and a positive 3.9. When you combine those, you're going to get 1.1x. And then I'd like you to do the same thing for the 5.3 and negative 7.1. 7-24, your goal is to figure out what fraction of things you're dealing with. The biggest trick I can give you is that this is 60% of the total. And so if this portion is 60, the remaining part is 40%. Okay. And you can break this down into smaller pieces if you want. 40 is pretty easy to just divide by 2. And so then you have a little 20% piece and a 20% piece. And half of the 28 students is 14 and 14. So every time you have 20%, you have 14. So you can just break this up into 20, 20, 20. And each of those into 14, 14, 14. Find all the total there. Okay. 7-25 is going to remind you about a thing that we did a long time ago called a tree diagram. And it wants you to do all the different bouquets he could make in this problem. So he has to choose one kind of greenery and one kind of flower. So his choice on the greenery is 2 choices. He can choose either a fern or a leaves. So this could be F for fern or L for leaves. And then afterward, he has 3 choices for sunflowers, or for the flowers for his bouquet. So he has 3 options here, which is daisies, carnations, or sunflowers. So I will just use one letter for that. Daisies, carnations, and sunflowers. And you do the exact same thing over here. Daisies, carnations, or sunflowers. So if you want the probability that he's going to use ferns, that's a pretty easy one. There are exactly half of these bouquets that use ferns, because it's the entire left side. What's the probability that he does not use sunflowers? So here's the sunflower outcomes that I just labeled in blue. So that means there's 1, 2, 3, 4 options out of the 6 total where he does not use them. Okay. And how many of these have leaves with carnations? So figure out there is exactly 1 option. That's the leaves and carnations path. 7-26 is going to remind or work with you on some old statistics information. And the idea is, first of all, it says read the math notes box in this lesson. So please go read the math notes box in that lesson. This is meant to be a review topic where you are finding the quartiles and the interquartile range. And step 1 of having any set of data points is to line them up from least to greatest. And that's what they did here. They took these 9 numbers, they lined them up 2, 7, 9, 12, 14, 22, 32, 36, 43. And in order to find the median, you count inward. So you count 1, 2, 3, 4, middle number is 14 in this case. And then in order to find your first quartile and your third quartile, you are looking at the median of those halves. Remember, median is middle. And in this case, you might have 2 numbers tied, such as 7 and 9. And then you add them up and divide by 2 to get 8. And then it gives you a definition for interquartile range. So when you start this problem off, arrange the numbers from smallest to greatest, or least to greatest. And then find the median. And then after you've found the median, use the lower and the upper half to find the first and third quartiles. And then you simply subtract those to find the interquartile range. So that's your lesson and homework help. If you want the updates, hit the bell, hit the subscribe. said the YouTube thing. See you guys. Good luck.